Hey guys, it's Ms. Damaso. Today we are going to talk about section 10.4. We're going to talk about segment lengths formed by chords, secants, and tangents. This is our week 7 video 1. So today, as you're watching this, it should be Monday, May 11th. This will be due on Thursday. Our last topic we talked about was 10.5. We talked about some tangent lines in a circle. We're kind of backtracking now. We're going back to 10.4. And still talking some more about circles and their properties. So let's get ourselves started. Remember, of course, that you can always print these off and follow along with me from the Edmodo assignment. And then if you don't want to print them off, you're more than welcome to do them via just on a note or on like a piece of paper in your notebooks. Okay, so let's get ourselves started. So today we're going to be talking about segment lengths that are inside of circles or outside of circles. They're formed by intersecting chords, secants, and tangents. So the first type of intersecting chords you're going to see are intersecting chords or secants, so segments essentially that are inside of the circle. Now, when we have two chords that are intersecting on the inside of the circle, what we can do is this. I find one of the chords. So here's one of the chords, this segment. So segment A is just this first half. Segment B is this second half. There is a property that if I am to multiply segment A times segment B, it should be equal to the other segment that is inside of the circle, which would be C times D. So that's my first type of intersecting chords that we're going to see. The second type are intersecting secants that are outside of the circle, right? So you see how these lines were just inside the circle. In type 2, I've got what looks like a line that's outside, a line that's inside, a line that's outside, a line that is inside. This one is just a little bit different. I have a rule here that says if, again, I look at this one long segment right here, I take the outside piece, which would be A, and multiply it times this whole segment. And this whole segment would be A plus B. That is equal to the same thing for the other segment. I take the outside piece, which is C, times the whole thing is C plus D. Okay, so you should have two sides that are exactly what you're noticing here is whenever you've got some segment lengths that are intersecting, they should be equal to each other. The last type, type 3, is an intersecting secant and tangent outside the circle. So you see you've got one line that's outside of the circle, and then you've got another segment that has an outside piece and an inside piece. So this one, what you're going to do is you're going to take the shorter side that's just outside, the A piece here, and I'm going to take that piece, I'm going to multiply it times itself. So I'm going to do A times A, or A squared. This piece right here is equal to this segment length over here, but I'm going to set it up the same way I set it up in type 2. So it's the outside piece times the length of this whole segment is B plus C. Okay, so those are the only three types of segment lengths that we're going to see inside or on or outside of a circle. Now for each one of the ones that we do below, what we're going to do first is we're going to determine if it's type 1, 2, or 3, and then from there we will actually solve each value or measure. Okay, so we're going to start with number 1 here. It says solve for x. So the first thing I'm going to do is I'm going to determine is this type 1, type 2, or type 3. I'll grab a different color here. What I see is that my segments are both inside of the circle, so this would be type 1. So because it's type 1, I'm going to take one segment and I'm going to multiply the two sides that are on that segment, which would be 14 and 15. So I'm going to multiply 14 times 15. And I'm going to set that equal to the other segment, which would be 10 times x. And then I'm going to solve this, and I'll zoom in. I'm going to solve this like an algebra problem. So 14 times 15 gives me 210. 10 times x gives me 10x. And then to get the x by itself, I divide both sides by 10. I get that x equals 21. And I'm finished. That's it. So let's try another one now. Number 2. Find the length of BD. So here's BD. I want to know what the whole length is. First thing I'm going to do is decide which type is this. I see all of my segments are inside the circle, so it looks like this first one here, type 1. So I'm going to set it up the same way I just set up that first question. So the first thing I'm going to do is I'm going to find my first segment length. Okay, so I'm going to highlight here my first segment is AC, and that would be 6 times 6. So that's my first one. Now I'm going to set it equal to the other 2 lengths here of the other segment, which would be 4 times 5x minus 1. And I put that in parentheses, right, because that's a whole equation. Now I'm going to solve this like a normal algebra problem. So 6 times 6 is 36. I have a 4 outside of parentheses, so I'm going to distribute it. So 4 times 5x is 20x. And 4 times negative 1 is negative 4. Now this looks like a really easy algebra problem. I'm going to get the x by itself, so I'm going to add 4 to both sides. I get 40 equals 20x. To get the x by itself, I divide both sides by 20. And I get x equals 2. That's great, but the question asks me to find BD. BD. Okay, so I'm going to take the 2, I'm going to plug it in over here to this x, right? So 5 times 2 is 10, and 10 minus 1 is 9. So this length right here is 9. The whole length of BD would be 4 plus 9. And if I had 4 plus 9, I get that BD is equal to 13. Okay. Number 3. Again, I'm going to determine what type this is. It looks like all of them are on the inside. So again, this is type 1. So I'm going to set it up the exact same way. And I'm just solving for x this time. So I'm going to highlight one of my lengths. It does not matter which one you do first. Do this horizontally one first. So the 2 numbers that match up are 27 and x plus 5. So I'm going to multiply those 2. And I'm going to set that equal to the other side, which is 24 and x plus 7. So I'm going to multiply 24 times x plus 7. And this is now just an algebra problem. So the first thing I'm going to do is I'm going to distribute the 27. So 27 times x is 27x. 27 times 5 is 135. Now I'm going to do the same thing on the right. I'm going to distribute my 24. So 24 times x is 24x. 24 times 7 is 168. Now I get all of my x's together, so I'm going to subtract 24x from both sides. I always like to move the smaller one because then I don't have to deal with negatives. So I get 3x plus 135 equals 168. Then I subtract 135 from both sides. I get 3x equals 33. And then my last step is to divide both sides by 3. So I get x equals 11. It doesn't ask me to do anything except for solve for x, so I'm finished. I don't have to plug anything in. Number 4, find TQ. Again, I see that these are all inside the circle, so again, this is a type 1 problem. So I'm going to set it up exactly the same way I did before. Okay, so again, it doesn't matter which one you choose to do first. I'm going to pick this first chord, RS. So the numbers that match up with RS would be 2x minus 5 and 18. So I'm going to multiply them together. So it's 18 times 2x minus 5. And I'm going to set that equal to the other side here, which is 2x plus 1 and 14. So I'm going to multiply those two together. 14 times 2x plus 1. And then I'm going to solve this like an algebra problem. So first thing I'm going to do is I'm going to distribute. 18 times 2x is 36x. 18 times negative 5 is negative 90. Be careful with your signs. Do the same on the right. 14 times 2x is 28x. 14 times 1 is a positive 14. Get all my x's to one side, so I'm going to subtract 28x from both sides. So I get 8x minus 90 equals 14. Add 90 to both sides, right, because I'm getting the x by itself. I get 8x equals 104. And then I divide both sides by 8. I get x equals 13. However, I want to know what side TQ is. So here's TQ. It's just 2x plus 1. Wherever I see the x, I'm going to plug in my answer of 13. I'm going to substitute it in. So 2 times 13. And then I'm going to add 1 to it. So 2 times 13 is 26. 26 plus 1 is 27. And I'm finished. All right. Number 5. First thing I'm going to do is I'm going to determine what type of problem this is. Now I notice that I've got some pieces that are inside, some pieces that are outside. Inside and outside. So it looks like I've got 2 different secants that intersect in and outside of the circle. So if I come up here, that picture looks like this type 2 problem. So I'm going to use this equation for this problem. This is a type 2. All right, so here's how it works. I take one of my secant lines. It does not matter which one I choose. I'm going to choose this one first in red. Okay, and here's how you do it. You take the outside number, which is 8, and you multiply it by this whole segment. And this whole segment is 8 plus 19. That's the red secant. Now we're going to do the other one. Same sort of thing. I'm going to take the outside number, which is 9, and multiply it times this whole segment is 9 plus x. Okay, now I've got just an algebra problem for myself. I can do the parentheses first over here. 8 plus 19 gives me 27. Okay, so this is the same thing. I haven't done anything else yet. And now I'm just going to solve this like an algebra problem. So 8 times 27 is 216. And over on the right side, it looks like I've got some distribution. So 9 times 9 is 81. And 9 times positive x is 9x. Now it's just a regular algebra problem. I'm going to subtract 81 from both sides. I get 135 equals 9x. And then divide both sides by 9. I get 15 equals x. So whenever you have these ones that kind of look like a party hat that go outside, you do the outside times the whole, outside times the whole. Number 6 looks like the same sort of thing. Outside times the whole, outside times the whole. So it's the exact same one as before. The only thing different this time is I want you to find the actual segment, not just x. So let's do it the exact same way we just did the last one. I'm going to start with this one on top here. Again, it does not matter which one you start with because you're going to get the same answer in the end. I do the outside times the whole. So the outside would be 10 times the whole thing would be 42 plus 10. 42 plus 10 gives me 52. So if you want to write that out, you can. If you want to skip straight to that step, you can skip straight to that step. Equals. Now I'm going to do the other one. Outside times the whole. So outside is 13. The whole thing is x plus 13. Or 13 plus x, whichever way you want to write it. Now it's just an algebra problem. So 10 times 52 is 520. On the right side, I've got a number in front of parentheses, so I'm going to distribute it. So 13 times x is 13x. 13 times 13 is 169. Now I want to get the constants to one side, so I'm going to subtract 169 from both sides. I get 351 equals 13x. And then to get the x by itself, I'm going to divide both sides by 13. I get 27 equals x. However, the question's asking me to find NL. So NL is the whole segment here. I already figured out that this x is 27. So to figure out the whole segment length of NL, I'm going to add 27 plus the outside piece of 13. And when I add those two together, I get that NL is equal to 40. All right, flip it over, a couple more in the back. Okay, this one looks the same again. It's the same sort of type, outside times the whole, outside times the whole. So this is type 2 again. All right, so it does not matter which one we start with. I'm going to start with this top one here. And notice that I keep doing it in two different colors. I think it's easier to see when you do it that way, so you don't get your things all messed up. Okay, outside is 8 times the whole thing is this plus this. So 3x plus 4 plus 8 equals, same thing now for the other side. Outside times the whole thing is this plus this. 5x plus 2 plus 7. Now, this is an algebra problem, but before I go to do my distribution here, my distributing of the 8 or the 7, I'm going to look inside the parentheses first. What I notice is that I can put some numbers together here. I can combine some like terms. I can add 8 plus 4 together here on the inside of my parentheses. I get 12 if I do that. I can also add together on the right side 7 and 2. And I get 9 there. Now this looks like a little bit easier of a problem, and now I'm just going to distribute on both sides. So 8 times 3x is 24x. 8 times 12 is 96. 7 times 5x is 35x. 7 times 9 is 63. Get all my x's to one side, so I'm going to subtract 24x on both sides. Always subtract the smaller one. I get 96 equals 11x plus 63. I now subtract 63 on both sides. I get 33 equals 11x. And then my last step is to divide both sides by 11. I get that x equals 3. All right, looks like I've got the same thing again for number 8. Outside times the whole, outside times the whole. So let's start with this one over here, XV in red. My outside number is 12 times the whole thing is x plus 8 plus 12. Now I'm going to do the other side. Outside times the whole. Did you guys hear that? It's the trolley downstairs. Okay, now again, I'm doing just some algebra. I can combine some like terms inside of my parentheses. I can add together the 12 and the 8, and I get 20. And then I can add together -1 and positive 15. Be careful, it's a -1, so this becomes a positive 14. And now it's just some simple algebra that I'm going to do some distribution. So 12 times x is 12x. 12 times 20 is 240. 15 times x is 15x. 15 times 14 is 210. All right, get all my x's to one side, so I'm going to subtract 12x from both sides. I get 3x plus 210. I subtract 210 from both sides. I get 30 equals 3x. I'm running out of room. I divide both sides by 3. I get x equals 10, which is great. But the question asks me to find yz. yz. So y to z is x minus 1. So I plug in my x, which is 10. 10 minus 1 gives me that yz is equal to 9. Oops, sorry. Okay, easy stuff. Last ones. As I'm sure you can probably guess, we did all type 1s and types 2s. Now we're going to do some type 3s. So the type 3, you take the segment that's by itself, you square it, then you set that equal to the other side, that's the outside times the whole. So I'm going to start with the side that's all by itself, and that side that's all by itself is 24. So I'm going to take that side that's all by itself and I'm going to square it. Then I'm going to set that equal to the other side, which is the outside, times the whole thing is this plus this. 18 plus x, or x plus 18. Now it's time for me to just do some algebra. On the left, 24 squared means 24 times 24. That is 576. On the right, I need to distribute this 18. So 18 times x is 18x. 18 times 18 is 324. And now it's just some simple algebra. I'm going to subtract 324 from both sides. I get 252 is equal to 18x. And then I divide both sides by 18. I end up getting that x equals 14. That's it. All right, number 10, we're going to set it up the same way. First thing I'm going to do is I'm going to find the one that's all by itself, the segment that's all alone, which would be this one right here, LM. I'm going to take that segment and I'm going to square it. Then I'm going to set that equal to my other segment here, PM, outside times the whole. Outside is 8 times the whole thing is 5x minus 1 plus 8. Now I've got some algebra. First thing I'm going to do, 16 squared. 16 squared gives me 256. Before I try to distribute, again, I'm going to make sure that I can do some simplifying here. I can combine some like terms. -1 and positive 8 gives me a positive 7. And now that I have that positive 7, and I've gotten rid of this part here, I can now distribute. So I'm just going to bring down the 256 again, and now I'm going to distribute. 8 times 5x gives me 40x. 8 times 7 gives me 56. Now I want to get the x by itself, so I'm going to subtract 56 from both sides. I get 200 equals 40x. And then I divide by 40 on both sides. I get x equals 5. That's great. The question asks me to find Pn. So I come to my picture. Pn is right here. Pn is 5x minus 1. So I take my x and I substitute it in. 5 times 5, which is 25. Subtract 1. I get Pn is equal to 24. All right, last two. Solve for x. Again, first thing I'm going to do is find the one that's all by itself, which would be this x over here. I'm going to take that, I'm going to square it. So if I square x, I get x squared equals, now I take the other segment here, I take the outside times the whole, and the whole is 27 plus 21. Okay, now I'm going to follow some order of operations here. I'm just doing some regular algebra. This stays x squared. I'm going to clean up the right side over here so I can add together, right? Parentheses is the first thing I always do. Please excuse my dear Aunt Sally. So 27 plus 21 gives me a 48, right? 48. And now I'm just going to multiply 27 times 48. If I multiply that, I get 1,296. Now, to get the x by itself, because right now I have x squared, to undo a square, I square root both sides. If you're going to use your phone, it has to be turned off of portrait. You have to have the lock off, turn it to the side, and find the square root that has a little 2 next to it. That means it's a square root. If you're using like a calculator, or you might have to click shift or secant depending on which calculator you have. I'm using a regular calculator, so if I do this, you find the square root of 1,296, just get a number smaller than it, I get 36. And it only asked me to find x, so I'm done. Okay, last one. Solve for x. We're still going to do the same thing. Outside, I find the one that's all by itself, which is 3x. So I'm going to take that. Oop, there's the hair there. And I'm going to square the whole thing. Then I'm going to set it equal to my other segment over here. And to make this a little bit easier for myself, I'm going to do what the whole thing would be. The whole thing would be 16 plus 9, right? The whole thing is 25. So outside is 9 times the whole thing is 16 plus 9, or 25. Okay. Now, the only part here that is a little tricky is this squared piece. I have to take the 3x and I have to square the whole thing. That means I have to square the 3 and I have to square the x. So if I square the 3, that means 3 times 3, 3 times 3 gives me 9. If I square the x, x times x is x squared. So you have to make sure you do the whole thing. Equals 9 times 25 is 225. Now I'm going to solve for x. This means 9 times x squared equals 225. So to get rid of the times 9, I'm going to divide by 9. I get x squared equals 25. And then to get rid of the squared, I'm going to square root it. The square root of 25 means what number times itself gets me to 25? That is 5, right? 5 times 5 gives me 25. So my final answer there is 5. Okay, we are now finished with section 10.4, segment lengths formed by chords, secants, and tangents. So we're finished with our video here. You can now go back to the Edmodo assignment, find your week 7 video 1 homework. Make sure you complete it and you show work for every single problem, and make sure you are taking a clear picture of your work as well as a clear picture of you holding your own work. If you do not take a picture of yourself holding your own work, I don't know that it's yours and I cannot give you credit for it. If you have any questions about this, please feel free to reach out to me. Otherwise, that's it for our, for our notes, and make sure you submit them by Thursday at 11:59 p.m. If you try to submit after, it will say error. It won't let you submit, and that means you waited too long and you are not getting a grade for it. So make sure you complete it on time. Okay? Thanks so much. Hope you have a really great Monday, and I will chat with you guys later. Have a good one.